So today we're going to be looking at solving for all solutions of theta for a given trigonometric function. Today we're going to be looking specifically at sine of theta. So if we remember last class, we could get a problem like this and we need to be able to isolate sine of theta to be able to solve. So let's go through that process first. So we'll get 2 sine of theta equals 1, divide both sides by 2, and we get sine of theta is equal to 1/2, right? And then from this step, we have a couple different approaches, right? We could solve it graphically, we could solve it using our unit circle, or we could solve it using our calculator, right? An analytic approach. So I want table 1 to do that by graphing it. I want table 2 to solve using the unit circle, and then table 3 to solve using your calculator, and then we'll come back together and chat about them. Sweet, so now that we've done that, right, let's hear it from you, table 1. What did we see? Great, so we had the graph looking like this, right? We have our sine curve oscillating up and down, repeating forever, right? It's just going to keep going on in both directions. We're going to plot that line 1/2 through here. Right, and then we can circle all of our intersections, right? We could go through in our calculator and find these by using calc intersect. Desmos pops them up for us right away. It's pretty sweet. And so, yeah, we see that this first one is pi/6. We could go through and find the other one in a similar fashion. If we wanted to use the unit circle to do this, right, table 2 is approached it this way. We're going to look at a circle like this, and then what's sine of theta represented by in our unit circle? Right, it's our y coordinate. So we're going to come up to 1/2 once again for y and put that value out, right? And so now we see these two possible triangles, these two possible thetas, right? Theta 1 and there, and then in red, the larger theta 2, right? A couple different options that we have there, right? Luckily for us, right, sine of theta equaling 1/2 is on our unit circle. And so that we see here, theta is equaling pi/6, that theta 1, I'll make sure we're in the right colors. Theta 1 is equal to pi/6, and then theta 2 is equal to 5 pi/6, right? And then we go through and do it in our calculator. If we're in degree mode, it'll give us that theta is equal to 30 degrees. Preferably right now, we're going to be working radians. It just makes solving these problems a little bit more straightforward because our input for our graphs is actually in radians, right? And so if we got that in radians, then we're going to get theta 1 is equal to, it's I think about 0.52, which is pi divided by 6. So you're not necessarily going to recognize that as pi/6, and that's okay. So what do we see here? What are the different numbers of solutions we got, right? Table 1, they got an infinite number of solutions. Table 2 got 2 solutions, right? And then table 3 got 1 solution. So what's the deal? Like, what questions is this bringing up for us about the number of solutions that we have, right? Good, nice. Are they unique? Is there a pattern? Nice, good question. How could we find them? Yeah, I like that one. Nice, sweet. So let's think about these questions as we go through into the next step to try to sort of answer them, right? Our graph is going to be that best representation of what's actually happening, but really focusing on, is there a pattern? And are these solutions unique, right? So for example, is this solution right here, that pi/6, any different from this solution? Or what about that? Right? Cool. So let's go here, right? So now either using that graph of sine of theta or your unit circle, I want each table to try to come up with their own way to find this second solution, right? This second little bit different solution. So, right, we could see there, right, once again with that unit circle, that we have these two solutions, right? So if we have an angle that's not on our unit circle, we might just have some generic theta 1, and then its other partner, right, theta 2. And so what relation do we see these two having, right? Awesome, that they're supplementary, right? So we know that theta 1 or theta 2, theta 1 plus theta 2 is equal to pi radians, right? So we can manipulate this a little bit to get a solution for theta 2 as pi radians minus theta 1. Great. So that gives us our solution there. We can see that graphically. If we sketch a quick sine curve, that 1/2 going through here, right? Oh, I'll make that a little prettier. Great, there we go. Try to make it nice and symmetric, right? That's important for this next step. Then we have pi right there. This is 2 pi, right? And each one of these curves is going to be symmetric. And so we can notice that if we have that 1/2 drawn in, right here, that this distance from 0 to theta 1 is going to be the same distance as pi to theta 2, right? These two are going to be the same distance, right? So that leads us to the same conclusion, that theta 2 is equal to pi minus theta 1, right? And what about analytical, right? If we're thinking to that graphing, right, we could think back to our identities that we learned earlier. And we have the identity that sine of pi minus theta is equal to theta. Right, so that's going to be how we go about finding our two unique solutions, right? But I want to make sure that we come back to these questions about whether or not there's a pattern or whether or not these are unique. So we see these two solutions as unique, right? You can see them here on that circle. We have theta 1 and then we also have theta 2. But this next solution on our graph is a full period away from our first solution. Right? So getting that solution is like this progress in the black. We're going to start here. We're going to come up. We're going to pass that. We're going to go all the way around the unit circle and then back here. Right? So that's just going to be a repeated solution. And that's going to be true for all of these solutions carrying out, is that they're just repeated solutions, right? That are just a whole period advanced. So we can end up with a general solution that looks like theta 1 plus the period, in this case 2 pi n, and theta 2 plus any number of those periods, right, where n is an integer. Right? And so that's going to be our process for solving for all theta of any given trigonometric form. This is specifically looking at sine theta, and next we're going to learn a couple different rules for how it manifests with cosine and tangent.